आवाज सुन लेना.
हाँ ठीक है. थैंक यू. So today we will take up the topic of the flexible manufacturing system, which is one of the advanced topic in the manufacturing processes, but it is also being included in the curriculum of the GATE, that is automated systems flexible manufacturing system. So what is the history of the flexible manufacturing system? The FMS system was first conceptualized for machining, and it required the prior development of the numerical control machine. This concept is credited to the development made by the David Williamson, a British engineer during the mid 1960s. So in late 1916, the first flexible manufacturing machining system was installed at the Ingersoll Rand Company in Virginia, and Germany implemented its first flexible manufacturing system in 1969 in cooperation with the University of Stuttgart. Russia and Japan, they have also implemented the flexible manufacturing system, FMS system, in 1972. So look at this one. What is FMS? If you see here, the this is the raw material storage roller conveyor. This is load unload station from where the components are loaded and also unloaded. Then the computer control completely this production line is a flexible manufacturing system in which it is controlled with the help of the centralized computer. Then the raw material storage, and this is the temporary storage of the area, temporary storage area. For example, this is the tools and this is the CNC one, that is CNC machine number one, and in and out area, that is loading and unloading. Then CNC machine 2, again in and out area. CNC machine 3, in and out area. Likewise, it is being arranged. So a flexible manufacturing system is basically an automated machining cell consisting of group of processing workstation interconnected with automated material handling and storage system. FMS is most suited for the mid variety, mid volume, and the production range. So the we know that the job order production, then the mass production. So this particular flexible manufacturing system, it is useful for the mid variety. Variety is between the job order and the basically the mass production, and also the production volume or the production rate. It is also in between the production of the transfer lines and the job order production, which means that this flexible manufacturing system, it is most suited for the mid variety, mid volume, and the production range type of manufacturing. Now, why to use the flexible manufacturing system? The external changes such as change in the product design and production system, because when we use the external changes such as change in the product design and production system, you are aware that this is the era of the competition among the manufacturing companies. If you take any company of the mobile company, okay, geyser company, washing machine production company, or otherwise the machining area, vehicles also, automobile also. So in each and every sector there is a steep competition, and the customer expects the new and new model with the new and new feature. What does it mean? That the product futures, they are subjected to change continuously, and we need to accept this product future. We need to develop such product future as per the requirement of the customer. So therefore, nowadays the product design and the production system, it is subjected to change. Then optimizing the manufacturing cycle time, because in flexible manufacturing system, it is the fully automated system wherein we look for the optimizing the manufacturing cycle time, means which means that in the normal transfer lines or the batch order production, the cycle time, manufacturing cycle time may be more, which can be optimized by using the automated systems like robot handling, like automated guided vehicle for the loading and unloading or the transfer of the material from one station to the another station, and we can optimize the manufacturing cycle time. Then reduce production cost, because of this flexible manufacturing system we can reduce the cost of the production. And overcoming internal changes like a breakdown, which means that in the flexible manufacturing system the path can be arranged in such a fashion that the internal breakdowns can be avoided. So, what makes it flexible? Basically, it is called as the flexible manufacturing system. So, what makes it flexible? Three capabilities that a manufacturing system must possess to be flexible. One is the ability to identify and distinguish among the different part styles processed by the system, means the different type of configuration, geometries, design which is processed by the system. So that is flexible. We can change the program, we can change the design as per the requirement. Quick changeover of the operating instruction, which means that very quickly we can change our tooling, we can go to the next line of action or next line of manufacturing of the new product or the different product with the different configuration, different attributes. Quick changeover of the physical setup, means the tooling which is being required and the setup, physical setup which is being required on the machines, that can be also quickly changed with the help of the flexible manufacturing system. So therefore these are the flexibilities. Now classification of the flexible manufacturing system, FMS can be distinguished according to the number of machines in the system. So, what are the typical types of the FMS? That is single machine cell, then flexible manufacturing cell, and the flexible manufacturing system. So, the it is classified into the three ways. That is single machine, then flexible manufacturing cell, and flexible manufacturing system. Now, look at the flexible, that is single machine cell. A single machine cell consists of one CNC machining center combined with a part of storage system for unattended operation, and completed parts are periodically loaded from the part storage unit, and raw work on the part are loaded into it. So this is the tool storage CNC machine center. You might aware that this is the tool magazine which is being shown here, which means that in this CNC machine, for example, 50 tools or 60 tools or 20 tools are being located onto the tool storage or the tool magazine. Whichever tool is required for the operation, that automatically the arm of the machine changes the tool quickly and replaces the tool in the this position, or in the spindle. This is the shuttle cart with pallet and the cart, and this is the empty cart. And here what happens, the shuttle cart empty means it is being loaded here, and part is being loaded into the spindle, and then the shuttle cart is moves empty. Once it moves empty, again it comes to the second side, that is pallet holder. Again the part is loaded onto the pallet holder. From this side, again from the pallet holder it goes to the through the pallet rack, again is go to the shuttle cart with the pallet and the part. And once it comes in front of the in front of this one, in front of the machining center, again it is loaded. So this kind of system is being shown where the single track is there, shuttle track is there, shuttle cart empty. This kind of track is used for the single machine cell. Here you can say that see that only one machine is there, and the basically the shuttle track is being prepared for this machine. Then second one, the flexible manufacturing cell. A flexible manufacturing cell consists of two or three processing workstation, typically CNC machine centers, plus a part handling system. The part handling system is connected to a load or unload station. So work transport system, you can see here these are the workstations arranged sequentially. You can have the different layout also. These are arranged sequentially as per the basically the shuttle cart. And here what happens once this shuttle cart is loading the basically the component into the CNC machine one. Once the operation of the CNC machine one is over, it is being transferred to the with the help of the shuttle cart to the second machine. Then again the second machine some operations are being performed. Then it goes to the third machine and again the operations are performed, and then it goes for the loading and unloading area. So this is your loading and unloading area, and the programming is being done in such a fashion that the sequential processing is being carried out onto the CNC machines like 1, 2, 3, and the operations are being performed. So part handling system is connected to the load and unload station. So this is called as the flexible manufacturing cell. Now, what do you mean by the flexible manufacturing system? So a flexible manufacturing system has four or more processing workstation connected mechanically by common part handling system and electronically. So this is the flexible manufacturing system has four or more than four processing workstation. For example, this is the centralized system, that is direct numerical control, and then the program is being loaded into the this each machines. There are more than four machines connected in a particular cell, connected in a particular flexible manufacturing system. And this is the automatic conveyor belt is there. Here you can see the robot uh, part is loaded and unloaded by the use of the robot onto the machine. Then again the unloaded part is placed onto the this conveyor, and again it goes to the second workstation. Again the robot is being used here. Then again it goes to the unloading is being done with the help of the robot. It goes to the third one, fourth one, like that. Okay, here in this case the basically the automated guided vehicles are also being used. What are the basic components of the flexible manufacturing system? The workstations, the workstations are there. It is arranged in a workstation, workstation number one, workstation number two, three, like that. Depending upon the number of machines, number of workstations are to be prepared. Usually in the FMS system it is more than four. Otherwise it will be FMS cell will be there. Then workstation, automated material handling and storage system, and computer control system, which means that in the flexible manufacturing system human intervention is being required for loading and unloading of the part in the beginning, and monitoring and controlling and checking. Otherwise complete control is the computer control. And automated material handling system is there, which means that after completing the work on the machine, CNC machine, the machine will communicate to the unloading device. For example, the robot is used for loading and unloading. It communicates to the robot. Robot then unload the component and place it onto the conveyor. Then again the signal is generated so that the conveyor it moves the part from one machine to the another machine in the sequence. or in a cell which is being arranged. And from the second machine again, the product which is being arrived from the earlier station, again it is being loaded with the help of the robot. Okay, once its operations are over on the second machine, again it will be unloaded onto the conveyor system, or the basically whatever the kind of shuttle track which is being used. And then likewise the product it goes in and out, and in the inside the FMS there is no human intervention which is being happening, and the complete programming or the complete computer control system is there. So workstation, that is a substation. Okay, so load and unload stations. So load and unload stations will be there. Then machining stations, then other processing station, and the assembly. Other processing station nowadays in the flexible manufacturing system, even the computerized inspection systems are being used, because in the olden days or in the conventional manufacturing plant, we take the product to the standard room wherein you check and measure the quality of the product which is being manufactured. So in process quality monitoring is being difficult in case of the conventional system. So in case of the flexible manufacturing system, we can have the automated inspection and measuring station, and we can have the staggered way of measuring the quality of the product, so that the complete product is manufactured, and then we will come to know that its product quality is not accepted, then we have to throw away the complete product. So your machining cost has also been wasted. Your time has been machining, time of machining also has been wasted, and at the same time, okay, the raw material costs also it is being wasted. So there will be a huge loss to the company if we rejection rate is high. So therefore what we see that in order to bring the lower rejection rate, okay, and if it is not acceptable in between, for example, 10 workstations are there, if we check the product after the workstation number 2, if its quality is not accepted, let us reject it at that moment only, without further processing on the workstation number 3, 4, 5, 6 up to 10. So therefore the other processing stations like inspection methods can be there, and the assembly station will be there. So this is the material handling system, automated forklifting, and the rail traveler system. You might have aware about this kind of forklift. If you are manually operated, if you have gone to the any industry, then you might have seen that this kind of forklift, which is operated by the human being, are being used. And this is the rail traveler, which travels along the basically the guided path only. Okay, moves from the one part to one location to the another location, or one workstation to the another workstation. You can see that on the rail traveler, the component of the engine is being mounted for the assembly. Then computer control, or the programmable logic controller, which is used in case of the flexible manufacturing system. So let me check whether it is going on correctly or not. ठीक है. So programmable control, computer control programmable logic controller, which is used, that is a PLC system overview, PC for the PLC programming, then screw terminal for input lines, input processing circuit, memory, then CPU, then output processing circuit, expansion connection. This is the communication to the computer, and power supply. And this part is nothing but the complete part is nothing but the PC controller. So this is PC for the PLC programmer. Allied signals flexible manufacturing system, that is central ship and coolant system. Then automated guided vehicle AGVs are being used, which moves on a path which is placed onto the floor. So these AGVs will track the path, and on the same path it can move. Otherwise, it can be designed to track the another paths also, different path also. So this is the AGV, that is automated guided vehicle, which is used into the flexible manufacturing system. The machining center, these are the machining centers which is being arranged. This is the wash station. Then the control room through which the complete operations are being controlled from the centralized place. Coordinate measuring machines under this is the coordinate measuring machine. Then part review station uh, under mezzanine, and the storage station. Once the components are produced, then it is to be stored here. This is tool setter, flexible build station. If any kind of operation is being required, it is a flexible station. Load and unload station. So look at the allied signals flexible manufacturing system. So several workstations are being shown, and how the AGVs are catering the need in the flexible manufacturing system. This is A5 machines FMS for machining. Okay, photo. So which is being shown here. Look at this one, flexible manufacturing system. The picture is taken from the top side, wherein this is what the workstation number one, workstation number two, workstation number three, four, five. Likewise, it is being arranged. Okay, this is the basically the track from where the components loaded onto this track, shuttle track. It moves to the second station, third station, like that. Then the human resources. So why, what for the human resources are being required? In this picture also, you can see that very few human resources are required, okay, onto the production line. In this picture also, you can see that at one or two places, at this place, two human beings are shown, and here one or two human beings which is being shown, which means that human intervention is less, and jobs to be performed by the human resources is of different kind in case of the flexible manufacturing system. So human are needed to manage the operations of the FMS functions. Functions typically performed by the human include the loading of raw material parts into the system, then unloading of the finished parts or assemblies from the system, then changing and setting the tools. Okay, so for changing and setting the tools, doing a setting, equipment maintenance and repair, and NC part programming in a machine. So the human resources are being required in case of the flexible manufacturing system for this kind of work only. That is OD, loading and unloading, programming of the machine, okay, changing and setting tool, equipment and maintenance and report, and unloading of the finished parts or assembly. Then layouts of the flexible manufacturing system, that is progressive or line type layout, loop type layout, ladder type layout, and open field type layout, and robot centered type. So one by one we will see the layout, but before that, again let me ensure that it is going on perfectly. Yes. So progressive layout, this is the starting point. That is, in the progressive layout, you can see that this is the loading point, and this part is nothing but the part transport system. So here the automated station 1, automated station 2, 3, 4, like that. And this is the unloading, which is being done manually. Loading also being is being done manually, and the workflow direction is being shown. So red part is nothing. Red part, red color, which shows that starting work parts, and here blue color is shown. Green color is shown for the completed part. So loading and unloading in the progressive layout is being done, can be done manually. Here the partial completed work part, it is being going. So in the progressive layout, you can see that the machines are arranged in a sequence, and the processing is being going on. Then in the loop layout, here the change in the arrangement is there. For example, the automated machine 1, automated machine 2, automated machine 3, 4, 5, and also the inspection unit is added into the this particular layout in loop layout. So you can see here starting work part, again it is given in the red color. So these components are going for the, it is shown in the red color. So here one component is leaving from the machine, one component is will be loaded, and again it goes to the second machine, third machine. Okay, this is called as the power transport loop, direction of workflow, fourth machine, fifth machine, and then on to the inspection station, which is fused with the loop layout of the FMS. The quality of the product is checked, and then it goes to the unloading area as a finished part with the green color. So this kind of layout is called as the loop layout. Then the ladder type layout and the open field layout. In the ladder type layout, you can see here the arrangement of the workstation is made like a ladder type. For example, this is loading and unloading area where the red color part is should be shown. That is the raw material or unfinished product loaded onto the machine one. Then from the machine one, again it goes to the in the ladder which is arranged in the machine 2. Then after completing it goes to the machine 3, or after completing it goes to the machine 4, and then the finished product is out of the system, and completed parts are again loaded and unloaded from the same point. Here we can have the different programming of this machine, different programming of the workstation, and depending upon the cycle time, even here the two parts are being shown here, so that we can utilize the machine time. And this kind of layout is also being used, which is called as the ladder type layout. Then open field layout. In the open field layout, what you can see that this is the recharge station. Here the machining station, which is also automated. One, two, three, four, five machining stations are there, which are arranged in the open field. And in the system, look at this one, AGVs are used, and the guide path of the AGVs is being given, so that the part is being moved with the help of the automated guided vehicle from one center to the another center. And then here the cleaning station or automated station is there. So here inspection automated, and then again the completed parts which is shown in the green color, and the starting work part shown in the red color. Then robot centered layout, in this case along the robot, because only single robot can be used to serve the two machines or to the four machines like that. So around this robot the machining centers are to be arranged. For example, this is money machine work table, this is machine tool. Okay, so once the part it is coming onto the conveyor or the basically this track, then the robot will pick up the part from the machine work table and load it onto the machine tool. Once it is processing is over, again the robot will unload the finished part and put it onto the this for the second system or to the conveyor, so that it can be moved to the second one. So second workstation. So this is called as the robot centered layout, where the robot is being used for communicating with the basically this is the communicating with the AGVs, or communicating with the material handling system, and communicating with the machine. So these are the some of the pictures of the flexible manufacturing system from the actual industries, where you can see that the robots are being used even for completing some of the operations. And in this case also, it is manufacturing cell manufacturing system. It will be very clean to maintain, and it will be easier to maintain, and most of the systems, most of the things are being automated. Then look at the application areas of the flexible manufacturing system. The metal cutting machining, then metal forming, assembly, joining welding, that is arc and spot gluing, surface treatment, inspection and testing. So these are the various areas wherein flexible manufacturing system is mostly used in the industries. So when the its evolution of the flexible manufacturing system was there around 1980, around 1990, and now almost 20-30 years span of time is over, and many of the industries have started using the flexible manufacturing system for the production of their product. Advantages of the flexible manufacturing system: to reduce the setup and the queuing time. So setup time is being reduced with the help of the FMS. To improve the efficiency of the FMS, to reduce the time for product completion, then utilize human worker better, improve product routing, produce a variety of items under one roof, improve product quality, serve a variety of vendors simultaneously, and produce more product more quickly. So these are the various advantages of the flexible manufacturing system, which one of the biggest advantages is serve a variety of vendors simultaneously, and the product variety can be changed very easily, and by designing the new product and then changing the programming of the system. So product quality is also being improved, since the automated machines and the manual handling system, work handling systems are not being used. AGVs and automated material handling systems are used, and we can utilize the human workers better, and production rate is also high in case of the flexible manufacturing system. Now, what are the disadvantages of the flexible manufacturing system? Naturally, the products are workstations are automated, material handling system is also automated, AGVs are to be used, so it is expensive compared with the conventional manufacturing process. And substantial pre-planning activity means pre-planning is being required to deal with the or to design with the flexible manufacturing system. Now look at the challenges with the FMS. Again, let me check whether it is going on. Yes, it is going on correctly. So let me take a biological break of 1 minute and then we will continue. our discussion on the flexible manufacturing system. So, what are the challenges for the flexible manufacturing system? Determining if FMS is best production system for your company, because this is one of the challenge. I told you that when you have to look for a system between the batch production and the mass production, flexible manufacturing system is one of the feasible solution. If you want to have the mass production, then you have to go toward the production by the dedicated transfer line, wherein changing the product very frequently is one of the difficult one, because product is being standardized, product is being design is being fixed. Therefore we use the dedicated transfer line where the cycle time is less, production rate is high, okay, and the more volume of production is there. In case of the batch order production, like shipbuilding, which is considered to be the batch order production, or any product manufacturing is there, like manufactured in a batches. In that case, the design is fixed. Okay, it takes a long time to produce, and we cannot have the product variety over there. So between the volume of the production and between the part variety or the product variety, this is what the gap which is there between the transfer line, dedicated transfer line, and the back order production, which can be fulfilled with the help of the flexible manufacturing system. So one of the challenge is determining if FMS can be the best production system for your company, and possible expansion cost associated with the implementing the FMS. So we have talked that automated material handling system, AGVs, robots, and the automated workstations are to be used. So therefore, possible expansion cost is there while implementing this FMS, flexible manufacturing system. So let me take one or two some numericals on this topic, and then we will go to the conclusion. Hmm. Hmm. So, in a flexible manufacturing system, the automated guided vehicles moves at a speed of 50
So, in a flexible manufacturing
moves at a
system,
speed of
the
50
automated guided
meter
vehicles
per minute,
moves at a
with the cover an average distance of 150 meter to deliver and 100 meter for return. If the time required for pickup and drop is 30 seconds each, neglecting the idle time, then the number of AGVs required to meet the demand of 50 deliveries per hour is. That's what you have to calculate. Answer is 5. How it is calculated? Delivery distance is 150 meter, pickup time is 3 seconds, returning distance is 100 meter, drop up time is 30 seconds, total is 1 minute. So total distance traveled by the AGV for one delivery is 250 meter. So AGV travels 50 meter in 1 minute. AGV travels 1 minute in the 004 minute. So total time is nothing but the traveling time plus peak and drop time plus idle time. So 5 minute, 1 minute, 0 minute, 6 minutes. So one AGV will take 6 minutes to deliver one product. So one product delivery takes in 6 minutes. So 10 product delivery takes in the 60 minutes, 1 hour. So if 1 hour, 10 products can be delivered by one AGVs for 50 deliveries per hour, 50 divided by 10, 5. So likewise, you need to find out the solve the problem. Then which of the following is not correct about the computer numerical control machine? Okay, the NC tape can be corrected and even optimized at the site of machine tool. So NC tape is not used in the uh, CNC machine. Okay. Then CNC can accommodate conversion of tapes prepared units of inches into the international system. The part program tape and tape readers are used only once to enter. The part program tape and tape reader must be used multiple times. So, which of the following is not correct about the computer numerical control machine? So, which of the it is not correct? The part program tape and tape reader must be used single time. This is not correct. Okay. So multiple times cannot be used in CNC system. You can see that the controller and all this part it is being shown here. Advantage of the CNC system is also being given. What is the correct order of the development of the following? Numerical control, computer numerical control, direct numerical control, distributed numerical control. So whether it is 1, 2, 3, 2, 3 like that. So it is 1, 2, 3, 4. 1, 2, 3, 4 means numerical control, then computer numerical control, direct numerical control, and distributed numerical control. So this is likewise the development is there. That is in earlier the NC machines were there, wherein the punch tape or punch cards were used. Okay, with the addition of these NC machines, then become the CNC machines. After that, direct numerical control are also called distributed numerical control were evolved with the advances of the technology of working remotely. So comparison of all the advancement in the NC machine. So likewise, it is shown. Then we will take another question. Numerical control is what do you mean by the numerical control? Is used for milling operation, used to produce exact number of parts per hour, controlled by means of a set of instruction, or used for only lathe operation. So controlled by means of a set of operation. So what is numerical control is being given? That is, it is the given name given to the method where the movements of the machine component are controlled by directly inserting the coded instruction in the form of numbers and letters into the system. So data input, data processing, data output, CNC machine, okay, and all these things, DNC machine and CAD CAM. Okay, correct sequence of operations of 4 CAD model related task is that is geometric modeling, engineering analysis, design review and evaluation, automated drafting. Okay, what is the correct one? That is, we do the geometric modeling, then the engineering analysis, then design review and evaluation, and then automated drafting. So the correct sequence of the operation of the CAD related operation for the task like geometric modeling, engineering analysis, design review and evaluation, and automatic drafting. The command generally used in computer aided drafting to draw a path of drawing using only one of the center and the center line. Okay. So likewise, these questions can be solved by you. Hmm. Now look at these questions. A flexible manufacturing system, the automated guided vehicle move at a speed of 50 meter per minute, cover an average distance of 150 meter to deliver and 100 meter for return if the time required for the pickup and drop is 30 seconds. This question we have solved just now. Now match the linear transformation matrices listed in the first column with their interpreter to see in the column 2. Okay. A CNC instruction G91. These are the codes in the CNC machine G91, G01, X3, Y40, F100 commands the movement of tool along the path at a feed rate of 100 per minute. G91 incremental format and G01 linear interpolation. The feed rate of the tool in per minute along the x-axis will be. So each x-axis, what is the solution? Correct answer is 60. Okay, so CNC instruction, that is commands to go N9, G91, G01, okay, G30, X30, Y30, Y40, and F100. So here you can see that each axis of the NC machine is driven by stepper motor drive with a lead screw. The pitch of the lead screw P is mm. Step angle of the stepper motor per unit is the alpha degree. The ratio of the gear drive in stepper motor drive is G, number of turns of the motor for each of the turn. The number of pulses required to achieve a linear momentum is X mm. So these are the some of the questions on the flexible manufacturing system, three axis CNC machines, more or less numerical will be there, gate, okay, which you have to solve. This kind of diagram can also be given where you are expected to solve this kind of number. ठीक है. So yeah, So let me go to the again my presentation, and then we will conclude with this today's topic. So here we conclude that the flexible manufacturing system is an kind of manufacturing revolution and in the field of automated manufacturing, and in future many more such kind of flexible manufacturing systems will be there in the industry. The automobile manufacturing systems, okay, leading companies, if you take any example, they are using this kind of flexible manufacturing system for their production. FMS can be designed to meet the specific demand of the each company, and it can be designed for the multitask operation. This is what the unique feature of the flexible manufacturing system. And FMS require substantial investment of time and resources. So these are the various things which are associated with the flexible manufacturing system, and it is a part of the automated manufacturing system which is used in the industry. So today we have studied the basic concepts of the flexible manufacturing system. What are the configuration or the types of the flexible manufacturing system? What are the attributes of the flexible manufacturing system? Then we have studied the advantages of the flexible manufacturing system, disadvantages also. Okay, what are the challenges before us to implement the FMS and how to use the FMS system? So, with this, now I will come to an end of my presentation or the discussion. And let me stop the screen. Yes. Okay. So, this is the flexible manufacturing system. This part is over today. Okay. Thank you.
Thank you, sir. Thank you, sir.